All right, so what's the formula I need for 1 and 2? All right, let's focus. Then what?
1 plus or minus r.
Okay, so what's the capital A stand for? That answer, yeah, but total amount, right? What's the little a represent? What you started with, right? The initial amount. What's the R represent? The rate of growth or decay, right? Now, when I put it in the calculator or in my formula, what do we do with that rate? Yeah, we change it to a decimal, right? We're moving a decimal point where? 2 places to the left. Okay? And then what's the N represent? The time, the number of years, right? We understand that? So for number 1, the total amount is the initial amount, which was $10,000. It says it's growing, so it's addition, right, at 5.25%. So when you put it in here, it's 0.0525. And then it says how much money will be in the account after 15 years. So N is 15, or T. All right, you can use N or T there. So that's all I got to put in my calculator. All right, 10,000, parenthesis, 1 plus 0.0525, close it up, caret 15. So $21,544. And to the nearest cent would be 26 cents. When we do money, we always go to the nearest cent, which was hundreds place. Okay? So that's the formula you're going to use for 1 and 2, depending on if it's addition or subtraction, growth, increasing, or decay, decreasing. So number 2 is A equals, and it starts out for population, 85,000 people. And it's decreasing, so it's 1 minus, and our percent was 2.8%, which is 0.028. And it says after 10 years, so that's to the 10th power. Okay? So those aren't bad once you know the formula, right? Right. So we go back to our calculator and put it in, 85,000, 1 minus 0.028 to the 10. And it's 63,985. So it went from 85,000 in 10 years to 64,000. Okay? Simple, right? This is an easy quiz. Just focus right now as we go over it, and it'll be very, very similar tomorrow, right? So this is one where some of you have gotten off to a bit of a shaky start. Summatively can bring that summative grade up with this tomorrow. So says write the inverse for the next two, all right? So instead of f of x, we think y equals, and then to find the inverse, we just switch. The y becomes x, and the x becomes y. Then what do I have to do from here? Right, I get y by itself. Okay? Make sure you're getting y by itself. I saw some people were getting x by itself. Okay? We already got x by itself, right? So like you guys said, add the 6. So we have x plus 6. Right? It's addition. So don't just put 6x. That means x times 6, right? So make sure you have the addition sign in there. And then what do I do with that 3? Goodbye. So you can leave it like this if you want. That's okay. Or if you want to separate it, where if you were looking at the, book answers, they always separate it. That's our symbol for f in, inverse. And they would go 1/3 x plus 2. 1 divided by 3 and 6 divided by 3. Either one's acceptable though. Most people just leave it like that, and that's fine. That's okay. All right. Number 4, same type of problem. Okay. So f of x, the y, I'm going to change to the x, and the 3/5 x, I'm going to change to 3/5 y. Okay, I switch the x and the y. So I'm going to subtract 3 to get y by itself. That's my first step. So I have x minus 3 equals 3/5. I don't like putting a dividing by 3/5. The other thing that kids mess up on, they get kind of in a hurry and their x's and y's look like each other and they're not sure which one's which. Right? Make sure, stay neat, take your time. All right, so I don't like dividing by 3/5. I would rather multiply by what?
Reciprocal.
Reciprocal, 5/3, yes. Okay, but remember, you have to do both of those times 5/3, not just one of them. All right. So if you need to put it in parentheses to remember that you're going to distribute, go ahead. So we got our y over here. And then 5/3 times x is just 5/3 x, or 5x over 3 if you want to put the x in the numerator. And then 5/3 times -3, put that in your calculator, it's -5. Okay? So that works out nice. That looks a lot better than -3 over 3/5. Right in that fraction. You got a fraction and a fraction. Okay, questions? Great, you got it? No?
No,
Why not?
I don't know how to do it.
You don't know how to do it?
No, I do know how to do it.
Oh, you do? So you got it?
Yeah.
Okay, I thought you said no.
Would it be wrong if you divided by 3/5?
It's not wrong, but it just looks really ugly.
Ugly, man.
UGLY, ugly.
Ugly.
All right.
Nice talk about that.
You okay with 3 and 4 now? Should we miss those? No, we shouldn't miss those, should we? John, sit up, cover your nose, and stay awake. So we have an exponential problem. Everybody knows that 5 to the second power is 25. Zach Blag, what's the logarithmic? Problem.
Log, would this still be considered base?
Yeah, log base,
Log base, 25 equals 2.
right, of 25 equals 2, all right? Don't make this 25 an exponent. Every year I got kids, will write it like this. They'll go log, like that. If you write it like that, what's my base? 10. Is that what you're trying to tell me? No. Okay, so don't do that. All right, we good on that? Should we miss that problem? No. Do not miss that. If you want to get Grandpa Vader mad, miss that. All right, 6, we're going the other way. We have log base 4 of 64 equals 3. So, Brandon, what's the exponent problem that goes with it?
4 to the third power equals 64.
Very good, sir. All right, let's not miss those. Those are like gimmies, right? All right, just write out the problem. You don't have to do anything but write out the problem that goes with it. Remember, they're inverses of each other, right? Exponentials and logarithmic are inverses. Okay, so the next 4 is supposed to express as a single log and then simplify. And it's always possible to simplify now. Why? We know how to use the calculator to answer all of these now, right?
Right.
The change of base formula. All right, so here's what you need to do to get full credit on 7 and 8. I need to see the single logarithm problem. I guess it's equals, right? So what do I do with the 32 and 4 since it's addition? Multiply, right? So what's 32 times 4? Okay, so I need to see that. Then I need to see the answer, which means just put it in the calculator. So I'm going to write what you're supposed to put in the calculator. Which one? The 28, 128 or the 4 up top? The 128, right. Make sure you close it off, right? The base, the 4, goes in the basement, right? In the bottom. All right, when you do that, you get a decimal. That's okay. Some of you thought, oh, I got a decimal, I did something wrong. You did not do anything wrong. It's okay to get a decimal. Okay? Questions? All right. Number 8, we have subtraction. So what do I do this time to make it a single one? Divide. So what's 28 divided by 7? 4. And then again, I'm going to put log of 4, close it off, divided by log of 3 in the calculator. And that gives me 1.26. Yes, sir.
Can we round that up to 1.3?
Why? Why would you want to do that? Yeah, that'd be okay. I don't know why I went to hundreds. All right, number 9, it just says simplify. So we've got log base 4 of 256 squared. Okay? So what's the little rule we learned about that exponent for the 256? Move it to the front, right? So this is the same problem, 2 times log base 4 of 256. Okay? So you can put in your calculator 2 times log of 256 over log of 4. Or you could get that answer first and then times 2, however you want to do it. All right? So 2 log, oops, I don't need to put that extra one in next time. Close it off, remember, that's the mistake we make sometimes. And you get 8. Okay? So log of 256 divided by log of 4 is 4. Just don't forget to multiply by the 2. Okay? Get that right, Trent? I was trying to remember. You didn't finish that one. You didn't finish that one. All right. So if you went that square to get that, right?
Yeah.
That would work. But you still gotta put log of that big one divided by log of 4 to finish it up. Okay? So don't forget that. The last one. It says evaluate, meaning just put it in your calculator. So log of 729. 2 got messed up there. Log of 27. Actually, 27 squared is 729. So my answer is 2. All right. So can we do well on this tomorrow?
Yes.
Yes. Everybody said, say, I can.
I can.
Say,
I am your father.
I will.
I will.
You will do well. Right? Positive thoughts. All right, let's have a good one tomorrow. You guys been doing good on your homework.
I like forward that. I figure out
You need to practice, we need to practice anymore? All right, let's keep it down now. You can talk, just keep it down, don't get crazy.
That's hilarious. That's